Welcome to the webinar series on automation for instrument data handling. My name is Rachna Ananthakrishnan, and I lead the Globus team here at the University of Chicago. In this first presentation, I'm going to provide an overview of the Globus platform capabilities for automating end-to-end research flows. It'll be a mix of slides and demos. I'll start with core use cases and requirements. We see a wide variety of instruments at campuses and various institutions, everything from next-gen sequencers, light sheet microscopes, cryo-EM, to large facilities like the advanced photon source, all generating different types of data, different volumes of data. But there are a few core requirements we can distill out of that. So the first is reliable access to the data that is coming out of the instrument. An interesting use case there is also near real-time access so that data can be processed and feedback can be provided to the experiment itself, potentially adjusting how data is collected and how the experiment is run. But also access to the data later to the PIs and collaborators and such. The second one is self-service access control. So allowing the researchers who are in charge of the experiment to manage who has access to the data, when, and so on. And also integrating that permissions with a facilities permission database. So often you already have permissions set up, you know who should have access to the data, and integrating that so that it's automatic and data access is granted quickly without any manual intervention. The third part is data access to collaborators, people who are not necessarily on site, or people who are not necessarily even in the researcher's institution, having access to the data. Compute is a big part of the data processing pipeline, and often that is done across different classes of compute systems, sometimes near to the instrument for, again, for these feedback and insights, and some of the reconstructions or large processing is leveraging resources that a researcher has allocation to. So the big focus of this presentation is being able to automate all of this so it can be done at scale. And by that, we mean managing data that is of various scales, so large amounts of data that are coming in, but also large number of users. If you're a facility and you have lots of different users come in, or lots of different points in the instrument where people are using it, how do you provide a system where all of the data handling and the pipeline for managing data that is coming out of the instrument is completely automated? I'm going to elaborate on one use case here that'll help shed light on some of the aspects of doing this at scale and trying to do a quick turnaround on the data. This is a group out of the advanced photon source at Argonne National Lab, and they are working on serial crystallography. So where they have a chip that has thousands of embedded crystals, and they're essentially imaging all those crystals. And when the data is coming out of the instrument, once 1,000 has come out, they want to be able to do a quality assurance process to be able to see if the chip is good and if they want to continue processing it and using their compute time for analyzing the data that was pulled out of that chip. They want to then do analysis in batches. If it's good, move through and do a full reconstruction, visualization, be able to extract metadata, and ultimately publish this data. So somebody can come in via a portal, find the data of interest and download it, right? All of this requires lots of different tasks. There is compute tasks, there is data movement, there's compute at different facilities that have different security requirements. There's also a user in the middle, somebody who's actually checking whether the quality, so that after the first 1,000 crystals were imaged, somebody is actually checking to see whether the chip was good and whether they want to continue with it. So there's actually a user in the middle step itself, right? So if you want to automate something like this and make it such that the turnaround time on this is really small, then you need a system that is reliable and can allow them to scale and run many, many of these when they do get access to the beamline and they're gathering data, right? So given this, let's look at what are the capabilities in Globus to support this, right? So the first thing I'll mention is the timer service. This addresses a very specific but important use case of being able to do scheduled and recurring transfers. This is a software as a service, so just using your browser or a client application, you can ask for transfers to be repeatedly run or run at a particular time and fully automate that process. We see this used a lot for backup. We see this used when they want to wait for a period of time and then start transfers. So once the data is collected, starting transfers, right? Very, very simple, very specific use case. And it's something that you can just do from our web UI. Second one is our command line interface. Globus has always been a platform as a service, which means we offer open APIs, and you can directly integrate and leverage a lot of the capabilities. We also have a Python SDK and a command line interface. So you can write your own automation scripts or applications that manage the different steps from the data pipeline and leverage Globus capabilities where needed as well. But recently we released a Globus new service, Globus Flows, which looks at addressing the pain points of doing all of that automation management in an application on the client side. So it's a comprehensive task orchestration service, and it alleviates the need for you to write client-side applications where state is managed and error reporting is handled and so on, and allows all of that to be done for you by the service. And you could just use it for your automations to run very reliably and at scale. So what does this provide? So it's a managed, secure, reliable task orchestration. And by that, we mean it's a hosted service that can provide all of the reliability, error handling, restarts, reporting, negotiating security as each of the steps in a pipeline are accessing different resources. So all of the complexity in automating across different resources, all of that is managed by the service. Support for heterogeneous resources. So even just in the example I provided, we're going different storage systems from an acquisition machine that is probably Windows-based and local storage to going to project-based storage systems, different types of compute resources, potentially cloud, leadership class, small clusters, what have you, and being able to orchestrate something that is across all of those. For true scale, you don't want to be starting these pipelines manually or have a user start this. So you want to be able to support a model where it is triggered by events. A data set read is complete, a file read is complete, a transfer is complete, and you want to be able to start processing. So the model is, the service is set up for event-driven execution. And then lastly, it's extensible, where each of the actions that is used as a part of the pipeline is not something that has to be a Globus provided capability. So you can write your own actions and they can run anywhere on your campus. It could be another service that somebody else is running for you that you want to use. All of those can be integrated into your pipeline. And that allows you to build custom things. So a domain-specific metadata extractor is a good example of that. So what does this look like in practice? So the Flow service is the platform service that we operate and run. Users define a flow, so they describe what the pipeline should look like and deploy that into the Flow service and manage that. Each step in the flow is an action, and the action can be literally anything. In the schematic below, you see some examples. Could be a step of getting security credentials, transferring data, getting a digital object identifier. So we have an action that speaks with the data site API to get a digital object identifier. You can set permissions. So an action can be anything. There are some that we provide and others that you can write. And the implementation of the action is called an action provider. That's what is called by the Flow service to actually perform the task itself. And then lastly, the idea of event-based implies we want to be able to support triggers. So this is in progress where we are working on a trigger service which can consume events that are coming in and based on some conditions set by the user, trigger a flow that essentially starts the processing. Right? So those are the pieces that make up a flow and what the flow service does itself. So the first step in using it is to create and deploy a flow. This requires no programming skills. This essentially, the description is using a language like JSON or YAML, so declarative languages. And you define the flow. You talk about, you essentially describe which action should be called, how the input and output behave, and there is a shared state across all of these as well. You can also do conditionals within the flow definition, so you can have a choice and decide what actions get run and so on. Once it is deployed into the flow service, you can set policy in terms of who can see it, who can use it, who's allowed to run it, and so on. So you have a lot of control in terms of how the flow that you've deployed is used. And on the other hand, you also don't need every end user to deploy a new flow. A beamline, a particular instrument facility, a particular type of methodology can write their own flows and deploy it, and then give permissions for users to just use it. Once it's deployed, the users can come and search for these flows. This is in fact using the Globus search service, which is a scalable search service that has permissions and visibility built into it. So we take the flow definition and the permissions that have been set on who can find it, who can run it, and put all of that into the search service. And you're seeing an interface into discovering these flows, right? So users can come and discover. If they can run it, then you see those start buttons on the web app. Web app is one way you can start and manage flows. We certainly have extensive support for it, but again, there is an API. So you can do this via your own application. We also ship a command line client, and you can use that to do all of this, deploy flows, start flows, and manage the run and so on. You could also start these runs based on some triggered events. So when a file is or specific type is created, has been the one we've talked about, which is used a lot at instrument facilities. So you can then have something that is watching for those events and then start a flow itself. There is extensive API and web app support for managing these. You can see how the run is progressing. When you start a flow, a run is started. That instance is a run. You can see how it's progressing. You can check the status. You can cancel it. You can also set policies for others to manage and monitor those things. If you are a user of the Globus data transparent access ecosystem, or if you're an admin, you would see the kind of policies we support for administrators to manage and support the users. Very similar things have been moved over to this service as well. So you should be able to troubleshoot and look at the status and who's running and what is running and so on. I'm going to switch now to a demo here for showing you how to start and run from the web application. So this is the Globus web application, and we have a new section here called Flows, and that's the part of the web app that has all of the flows that you can discover. There is a library tab. That's where I would come and search for flows that I have access to and I want to run. So I'm going to look for a flow called Move. This is a flow that we as in the Globus team has developed and deployed. And this is a very simple two-step. Essentially, it moves the data from source to destination. And if the data has been successfully moved, then deletes the copy at source. So if you look at a flow, you can see the definition. Like I said, it's written in YAML or JSON. And each step in the flow has a name, and then it decides it has error handling as well. It also talks about what the next step is and so on. And then a flow author can also define an input schema, and that tells us what kind of input needs to be given for this flow to run. Right? You can also set roles. You can see in this case, the flow is managed by a group of Globus where the members are Globus team members, but it is set up for all authenticators users to run the flow. So you can log into Globus and find this flow and run it yourself as well. So I'm going to start this flow. When I start the flow using the input schema, the web app dynamically generates a form for the user to provide input that is needed to run this. Right? So this is a move flow, so you should expect a source and a destination. I am going to use the Globus tutorial endpoint as the source. And I'm going to pick a folder that I staged for this purpose. And then for destination, I'm going to choose another guest collection that I have. When doing automation, using of guest collection is best practice. That way, you can fully automate it without a user in the middle. If you use mapped collections, then the mapped collection policies, as determined by the administrators, will make the user come in and authenticate every so often. So I'm using a couple of guest collections here. These are labels for me to identify the transfer and the delete actions. When I start a run, I can also set tags. This allows me to come and find runs of interest. And when I'm starting one or two of these, it really doesn't matter. But when you're running this at scale, we have runs 40,000, 50,000 runs of a single flow for every experiment they're running these things. Then to be able to come back and sort and find runs of interest, these tags are really helpful. And then lastly, I'm going to label this. So when I start a flow, this is submitted to the flow service. The flow service manages the run completely end to end and ensures that it is managed in terms of any errors, any retries, and so on. I can go see the run details here. Look at the event log. You can see each step is shown here. I can also just go to the runs page, where you can see my run is still in progress. These are some other ones that I've done before, right? I can also allow other people to monitor and manage these runs as well. So that's one example of starting this from the web app. There are a couple of flows that we have built. The move one is the one that I demoed and showed you. Another one is a two-stage Globus transfer. So in some cases, it is useful to be able to stage the data from a machine at the institution to a better provisioned machine, and then take the data out of the institutions, things that are sitting in a science DMZ or has more capacity. So those are two-stage transfers. So what this does is moves the data to the intermediary storage, then submits a second transfer to move it to destination. And when the transfer is successful, deletes the data from the intermediary, right? So these are, again, ones that we have deployed, but is available for anybody to use. So you can go in and start these from the web app. The second way to do this that we talked about quite a bit for automation and scale is using triggers to run events. So I'm going to do a quick demo of that. This is the demo scenario that we have set up. I have an EC2 instance that I'm going to think about as the acquisition machine that is sitting right next to the instrument, right? And that is running a Globus Connect personal endpoint. We find that most often the acquisition machines are Windows-based. So Globus Connect personal is often used. And in all of this, it doesn't matter whether you're using Globus Connect server or personal. On the other side, I want this data to move to a project store. This is something that is hosted and I have access to it at the University of Chicago. And again, I'm using a guest collection, so this can be completely automated, right? And this is a GCS, Globus Connect server that is being run by campus. I'm going to install a monitor script on the acquisition machine that is watching for files of a particular extension. And then when that condition is met, it triggers a flow run. It essentially starts a run. And the first step, transfers the raw files into the project store, and then sets permission for a group of users to access it. And that just using the Globus sharing capability, right? Pretty simple two-step flow, but it's used a lot to be able to get the data out of the acquisition machine as quickly as possible. So let's look at how that works. So this is my this is that EC2 machine, my demo acquisition machine. And actually, all of these scripts that I have here are open source and available through the Globus GitHub repository. And I have resources on that, right? So the trigger script here watches a directory, and that's my data directory that is here. So it's just watching this folder, and it's looking for a file with a .done extension. So when I start this monitor script, it's now watching this folder to see if there is any data. This is using iNotify. So it's just watching for file system events. And then when a condition is met, it's starting a flow, right? So let's create a new project directory here. So let's say this is another run. So I create some files. And when I create one which has the done extension, then this is going to start a flow. And the input to the flow has this folder, the /data/projects folder, project 4 folder, so that all the data in that folder is copied over. Right? Now I can go to the Globus web app and see the run has started, and I can see the status of the run. Look at the event log. It was very small, so it very quickly completed, right? And like I said, the tags, when you run a flow, having these tags are so useful as it scales. So you can see tags here, XPCS, SSX have about 44. This one has about 36,000 runs, and this one has 4,000 runs. So when you start these things programmatically and start using them at scale, these tags are very useful to be able to slice and dice and find runs of interest. So a lot of mine have this tag, and I can see the run that just completed. Right? It's a pretty straightforward way of starting these, but pretty powerful in terms of using events to be able to trigger these pipelines and reduce the time it takes to be able to do these things. So let's switch a little bit and talk about these action providers, which are used in each of the steps in the flow. So an action provider at its basic is just a service endpoint. So you can take any service that you have or any functionality you have and wrap it as a service, and it can be called from the flow service. There is an API it needs to comply with, and that's it must be able to call run, check status, cancel, and so on. There is an action provider toolkit that is made available that allows you to write one from scratch or wrap one of your existing functionality into an action provider. Everything that you see in blue here are Globus provided. A lot of the Globus functionality is offered as an action provider, so it can be used from the flow service. We also have had other people build their own action providers. funcX is for compute, describe, prompts users for metadata. Extract is work from the University of Chicago, where somebody has allowed large-scale metadata extraction and wrap that as an action provider and so on. So like I said, the platform is extensible, so you can wrap any functionality you would like. I just want to touch on funcX because compute is a pretty big part of pretty big part of the pipelines for data that is coming out of instruments and how it's processed. This is work out of the Globus Labs team, and it's transitioning into a service that is going to be made available as a part of the Globus platform. And it provides a managed functions as a service. It's again a hosted service that allows you to reliably execute functions on remote endpoints. So again, the management aspect, the reliability, all of that is handled by the hosted service. And you can ask for functions to be run on any kind of compute, anywhere there is a funcX endpoint running, whether it's from a laptop or to a cloud, using cloud resources or leadership class facilities, right? So it's very simple to use this service where you're able to do some test runs on your laptop and then just scale it up. Most importantly, from the perspective of this presentation and this talk, funcX provides a programmatic way of accessing compute. So we are able to set that up in such a way that compute resources can be called as an action provider. Right? So that's a pretty important part of this. So to close this out, I want to go back to the original use case I described. So the serial crystallography friends, they had this pipeline that they needed when data came out of the instrument. And they defined a flow, and this is sort of what their flow looks like, right? So first they transfer the raw files, then they launch a QA job. This is those 1,000 crystals that they needed to make sure that the chip itself is good. And then it sends an email to a user. Somebody actually comes and looks at the image and the data and decides whether to proceed using their cycles on the leadership class facility to do a full analysis. Then the full analysis is done, visualization, metadata is extracted. They move the data to where it's going to be served from, right? The repository essentially, set permissions. Sometimes it's embargoed data, so you make it accessible to some people, and then sometimes it's open, and then push the metadata to a search index, right? So all of this is completely automated. As the data is coming out of the instrument, these flows are continuously run, and the whole life cycle is taken care of for them. From a user perspective, you're then able to go to a portal like the one shown here on the slide. And you're able to search for the data, be able to see thumbnails and things like that, and access the data, right? So all of this was done as a flow, and their time to results was dramatically dropped. They were able to reduce, and we also were able to eliminate the complexity on their side. The infrastructure they had to maintain and the scripts they had to maintain to be able to call all of these steps and check for errors and all of that. So that's the kind of capability that the Flow platform brings. So with that, I want to mention a couple of other presentations that are coming up in this series. The next one is on October 21st. That is going to provide a hands-on explanation on how to build and run these flows. We are going to use Jupyter Notebooks as a teaching tool there. And again, these are all available as resources for you to go try as well. And it'll talk about how to build these flows and deploy them so you can make it available for your users. And then the last presentation in this series is on November 3rd. And we are going to talk about automatically triggering these flows. So some of the demo that I showed you, that presentation will talk about how to set it up and provide scripts and tooling for you to do that. It also provides, it also will talk about using funcX, so integrating compute into your pipelines. So I'll close this out with a thank you to our funders. Both funcX and Automate were funded by National Science Foundation grants. And also a huge thank you to our subscribers who allow us to sustain these services and operate them and also grow them further. And the last slide here has support resources. You can always start at docs.globus.org. That is the root of all our documentation. And if you have any questions, you can email us at support@globus.org. We can also set up some time to talk with you about potential applications. If you think there are use cases that may fit and you would like to discuss how you could use this, we are happy to set up some time to discuss that with you as well. Thank you.